To show that the line L1 lies on P, let's first try to prove that a point that is on this line L1 will also be a point that is on the plane P. One convenient point that I can find on L1 can be obtained from the position vector here, because this represents the position vector of a fixed point that is on L1, which means that a possible point that is on L1 will be 1, 2, and minus 3. So I want to check whether this point, which is already on L1, whether it lies on P. To do that, I'm going to take its position vector, which is 1, 2, minus 3, and plug it into the equation of the plane. So this dot 1, 1, 2, this is equal to 1 plus 2 minus 6, which is minus 3. What does this tell me? This tells me that the point 1, 2, and minus 3 lies on the plane P. So this, I'm going to call it my statement A. Next, I'm going to check whether this line L1 is parallel to P, because if there's a point that is on L1 that is also going to be lying on P, and yet at the same time this line L1 is parallel to P, that means L1 has to lie on the plane P. And to check this second criteria, what I'm going to do is I'm going to take the direction of L1, and the direction of L1 can be obtained from here because this is a vector that is parallel to L1. So I will take 2, minus 4, 1 and compare it to the normal vector of P. So if I can check and realize that this vector and the normal vector to P, they are perpendicular to each other, that means L1 must be parallel to P. So this is 1, 1, 2. I want to check the angle that is between this and this. So what I'm going to do is I'm going to take 1, 1, 2 and dot it with 2, minus 4, 1. This is 2 minus 4 plus 2, and this is 0. That means what I can see is that L1 is parallel to the plane P. This I will call it my statement B. So for statement A and statement B together, this tells me that L1 lies on the plane P, which is what the question wants us to show. Next, I want to find the coordinates of the point where L2 intersects P. In the previous part of the question, we know that L2 and L1, they are supposed to intersect. And if now we have found out that L1 intersects P, that means the point of intersection between L1 and L2, let's say this is L2, they must cut at the place where L2 cuts this plane P also. And from the previous part of the question, we have already solved for the value of lambda when L1 and L2 intersect. From the previous part, the value of lambda is minus 1. So if I were to call this point, let's say N, the point where L2 and L1 meets, which is also the point where L2 intersect P, for that point N, I can find it by substituting lambda as minus 1 from part 2 of the question. So ON is going to be equal to 1, 2, and minus 3 plus lambda is minus 1 of 2 minus 4, 1. So the position vector of this point N is going to be 1, minus 2, minus 1. This is 6. And here is minus 4. So the place where L2 intersects P has a coordinate of minus 1, 6, and minus 4.